In this video tutorial, you will learn how to connect multiple tables using SQL joins. Hello, my name is Anna, and welcome to Elsewhere Academy. Here we present the most useful tips and tricks in data management for beginners. And today, we will learn how to use joins in SQL. With joins, you can connect two tables into a single data set and perform operations on the combined data. Today we will see a few ways how to connect two tables and also have a look at how to combine more than two tables into a single data set. I've presented the very basics of SQL in my previous video. Watch it to learn what is the database, what types of databases we can use, and which ones work with SQL. Just click the card above. I will start from the example dataset review. Get access to the same data by downloading a practice sheet. Find it in the video description. This time I will use postgreSQL as my RDBMS. If you want to jump right to the SQL syntax review, use timestamps in the video description. The dataset we will use today is stored in a GSheet. Find it in the video description. It contains 4 tabs: applicants with data about our candidates, marketing channels from where we received each application, positions list with the departments, and managers per each department. Review the data before uploading the tables. The formatting is very important for SQL. Keep the numbers, like salary for example, without commas or dots. Use a single format for dates. Also, for column names, use only lowercase letters, no spaces or symbols. This way, it will be easier to refer to those in an SQL syntax. Each tab is a separate table for RDBMS. You should download each one separately in CSV format and save on your computer. Go to File, Download, and choose the needed format. I have already prepared my database in advance. Remember to use lowercase letters for database and table names. These ones are case-sensitive in SQL queries. If you need to set up postgreSQL, use the link in the video description. To work with it, you will also need to upload a graphical user interface client called pgadmin. Before we move to practice, let's discuss the logic of how joins work. We need joins to perform operations with data stored in the current table in case a criteria for the operation is contained in a different one. In the applicants table, for example, if I want to see average salary requests from Glassdoor applicants, I need the salary field from table 1 and the channel field from table 2. And join can help here. A join clause is used to combine rows from 2 or more tables based on a related column between them. This related column is called the join key. Let's have a look at our applicants table. Each row contains a single record of data about one application. We can see an applicant ID here. In the channels table, we can also find an ID field. If you will have a closer look at the IDs in the first rows, we see that those match. These columns will act as join keys. The join clause will connect each row where the join key matches. Remember to keep data type for join keys the same in both tables. So if it is numeric in applicants, it should also be numeric in channels. So in the output, the first row will look like this. And this will happen for all of the matched keys. Let's have a look at one more example. In the applicants table, I have the position index. I need to match the exact position names for each applicant based on this index. I have the needed list in the positions table. Although the applicants table has over 200 records and positions table has only 11, this is not a problem. The values from the positions table would get copied for all of the matched rows. You see the 2005 index. In the positions table, this one stands for the Customer Success Manager. I will copy this line. If we apply join, this line will appear next to each applicant record with the same position index. This is a general logic of how joins work. Of course, there won't be a 100% match in each case. So there are a few ways to connect tables. Inner join returns records that have matching values in both tables. Here is a simple logic schema to explain this. The syntax is next. Type table 1, inner join, table 2. Then, to state the join key, use on table1.column1 is equal to table2.column2. The word inner is optional. A simple join clause works the same, but I will state inner join in my examples to keep track of the logic we use. Right-click on the table, Query tool. This is how we get access to the editor. For example, we can use select asterisk, that stands for all fields, from applicants, inner join, channels, and these are the two tables used, on, and here we should state the join key, applicants.applicantID is equal to channels.id. In the output, we will see only the applicant records that had a matched ID in the channels list. All of the records from both tables that did not have a match won't appear here. Left join returns all records from the left table and the matched records from the right table. The left table here is the one stated before the join clause, and the right one is stated right after. The syntax is next. Table 1, left join, table 2, on, table1.column1 is equal to table2.column2. If we use left join from the same example, applicants and channels joined by ID, we will see all of the matched records plus the records from applicants that did not have a match in the channels table. Where we had channels stated, those records now have null. If we switch tables places and click Run, the output changes. In fact, all of the records from channels appeared here. Those that did not have a match in applicants have null. But there are no applicants records with null channels anymore. Right join is the opposite of the left join. It returns all the records from the right table and the matched records from the left one. The syntax structure is pretty similar to the previous examples. As right join uses almost the same logic as the left join, some RDBMS, like SQLite for example, do not support it. But this is not a problem at all, just switch tables places. Also, left join is a bit more useful and often used, as you don't have to read your query backwards. A full join returns all of the rows from the joined tables, whether they are matched or not. You can also say that a full join combines the functions of a left join and a right join, as described in this schema. Full join is not supported by some of the RDBMS, like SQLite and MySQL. Let's connect applicants and channels on ID using full join. Run. And the output now contains both matched and unmatched records from both tables. And this is how joins work. In the output, you can see that in total there were 234 unique records, but 110 missed some of the data. Once you join a few tables, you can then use other SQL clauses. Now, let's have a look at more advanced examples. A great thing about joins is that you can connect multiple tables at once. Let's say I want to see which recruitment platform works best for hiring engineers. I have positions and channels stated in different tables that cannot be connected with each other. Thanks to joins, I will use the applicants table as a mediator. Type select all from applicants. Let's first connect applicants and positions tables. I will use inner join to see only the matching values. If I will miss any values in either applicants or positions tables, this won't work for my initial aim to connect channels and positions later on. The join key will be the position index. Type from applicants, and here we state a short name for this table to use later on. Let's type as app, inner join, positions as PO. And we connect those tables using the join key. On app.position is equal to PO.positionIndex. Run, and here is our new join table. Now, we should connect channels using the same inner join logic. Add inner join channels as ch on app.applicantID is equal to ch.id. Run, and here is our extended table. Now, let's specify the exact fields we want to see. Select position name, channel, and applicant ID separated by commas. I have selected the order of columns as I want those to appear in my final output. As all of those fields are based in a single database, we can refer to columns without table names in case column names are unique. Run, and here are the 3 columns we were interested in. Now, I want to count the number of applications per each position received via each communication channel. For this, I will use the count function for applicant ID. Type count and wrap the field name in parents. Choose a short name that will act as a column name in the output. Type as app number. Let's group the output by the position name. As it's the first column, I type group by 1. Run. That doesn't look well. I've got an error. It says that column ch.channel must appear in the group by clause or be used in an aggregate function. In this case, we should use channel as the secondary grouping field. So I type comma 2. Run, and now it looks a bit better. I can see how many applications I've received for each position from each communication channel. But a bit of order would also help. Let's use order by. I want to have all of the channels for a single position listed one by one. So I order by the position name first. Then, I want the most productive channels first and the least productive last. So I order by applicants count, descending. Type comma 3 DESC. And there we go, a nicely organized list. One last edit. There are many rows with channels that brought only 1 or 2 applications. So those are not that interesting for me. I want to see only the channels that brought at least 4 applications per position. This means I need to use a filter. There are 2 ways to filter data in SQL, using where and having. Watch our tutorial to learn how it works. Click the card above. Our choice will depend on what we choose as a filter criterion. Where works with the original data set. So if I would like to see the data for engineering positions only, I would add where after the from clause and type position name like engineer. Like helps us identify the data containing the stated value. And here are the stats for the engineering positions only. Remember to follow the correct order of clauses in your queries. If we would want to filter based on the channel name, where would also work well. However, aggregate functions are not allowed in where, as those are the derivatives of the original dataset. In this case, we should use the having clause. This one usually helps with the secondary filter criteria. And aggregate functions are allowed here. Having follows group by. We type having count applicant ID is more or equal to 4. We can't state an alias of the column here, unfortunately. Run. And finally, I have a well-organized list of the most efficient recruitment channels. You can combine different types of joins in the same query. Let's add one more table, managers. There is one manager who is responsible for a single department. You can use full join managers as MN. In the positions table, we have a department field. In managers table, we also have a department field. So we state on po.department is equal to mn.department. In case you want to refer to a department field later on, in select or where, for example, you will need to state which exact department you want to use from the positions or managers table. Use the same syntax as for the join key, po.department. Using full joins, we can identify the rows that had no data in the specific fields. Let's see applicants who did not have an allocated manager. We have two fields with IDs in applicants and channels tables. Let's select both as well as the manager field. And where manager is null. Run. And here are the applicant IDs that did not have an allocated manager as per our data. In this case, we should gather more information about those applicants, update our tables so that we have all of the needed join keys to combine all of the tables. Our last case for today is to see candidates allocated per each recruiter and manager. When you hire a person, there is a recruiter responsible for the communication and a hiring manager who needs a new employee. Let's select the manager, position name, recruiter, and applicant name fields. Run. And here we have an unorganized list. Also, in the end of the list, we see a few rows having null for the columns we're interested in. So let's add a criteria where manager is not null. You could also use an inner join with managers table to exclude values that do not match. Let's order by the manager field first, then by the position and by recruiter. Run. And here is our list. I hope now you know everything about different types of joins. In our future series, we will present even more interesting cases and functions. So subscribe to our channel and press the bell not to miss any of the Railsware Academy updates. Also, don't forget to click like. Railsware is a product studio. We have created Coupler.io, a tool to pull your data from various apps to Google Sheets. Click the link and try it today. Watch our SQL and Google Sheets tutorials to get the most out of automated data flows. That's all for today, and see you next time!